Let's look at the first one. It says, suppose an urn has B black balls and R red balls. If we randomly pick a ball, if the drawn ball is red, we put 2 red balls back to the win. And just think about this. So I have this urn. This is a box maybe. I have R red balls in it. And I have B black balls in it. I randomly pick up one ball. So suppose this ball turns out to be red. So if this ball is red, I have picked out this ball. How many balls are left in this? I have one less red ball now because I have picked up one ball, and I have B balls left. But then it says that what you do is you put 2 red balls back to the win. So what you do is the moment you do this much, you add back 2 red balls back, right? So what are the total number of balls that you now have? You have R plus B plus 1 balls, right? And how many red balls do you have? So you had R red balls, you picked up 1 red ball, and then you plugged in back 2 red balls. So you have R plus 1 red balls. This is what the first sentence says. If the drawn ball is black, this is not blue, it will be black. We put 2 black balls back to the win. This is also black. Just keep the same color. Back to the win. Then we randomly pick up the ball again. What is the probability that it is red? So it is possible that the ball that I drew was, so just like I did for red, it is also possible that the ball that I drew was black, right? So for example, let us go ahead and take this another case that I have R red balls and I have B black balls. And then I pick up 1 black ball and I just again put back 2 black balls. So ultimately I have B plus 1 black balls. And the total that I will have will be R plus B plus 1, right? Now it says, what is the probability that when you draw the ball again, it is red? So I need to find out what is the probability that the second ball drawn is red, right? So this is the case. The first ball drawn is red and the second ball drawn is red. Or the first ball that I drew was black. Make sure that you just keep the same color, please. The first ball that I drew was black and the second ball I drew was red. So first of all, find out the probability that I am drawing the first ball as red. So first case, when I first draw the ball, there were R red balls and total number of balls were R plus B. So if I have to draw the first red ball, the probability will be R plus B. Then the second red ball, as I just explained, the moment you draw a red ball, you have 1 less red ball, but then you put back 2 red balls. So totally you will have R plus 1 red balls. This is what we just saw, right? That totally you will have R plus 1 red balls. So the second time that you have to draw, you will be drawing out of this R plus 1 red balls. And this will be out of how many total balls? R plus B plus 1. So this is the probability of drawing the second red ball. Similarly, if I talk about black balls, you have a very similar thing happening. So initially there were B black balls out of R plus B balls. So this is the probability. You will draw this. And the second time you go ahead and you do that, I want to draw a red ball. Red ball are still R only, right? I added back black balls. Red balls are still R. But the total number of balls, even when I had this black ball being drawn, in this case, red ball are still R, but the total number of balls that I have will be R plus B plus 1. So this is what I have here. I will have R plus B plus 1 here. Now it's same. Simple. What you can do is you can take common. So what I have done is I've taken this part common. So from here, this and this comes out. So inside, I will be left up with R plus 1 in the numerator from here and B in the numerator from here, and denominator will be R plus B plus 1. So this will just cancel out. And I will have my answer as R upon R plus B. So the correct answer to this question will be A, which will be R upon R plus B. Let us go to the next question. It says a random sample of size 8 is drawn from a distribution with probability mass function given as this. So the PMF that you are given is this. Okay. It says the sample values are 1, 0, 1, 1, 0, 1, 1, 0. The maximum likelihood estimate of theta is. So I'm supposed to go ahead and I'm supposed to find theta's maximum likelihood estimate, MLE. But before I go ahead and do that, I need to go ahead and break it in a particular way. So if you notice here, it says this is when K takes the value 0 and 1. So what I'm going to go ahead and do is I'm going to rewrite this probability function. How? Look here very carefully. I am saying that when K is 0, so just think here. If I go ahead and I put K as 0, what will I get? Theta to the power 0. 1 minus theta to the power 1 minus 0. So it will be anything to the power 0 is 1 into 1 minus theta to the power 1. So this will be 1 minus theta. So if K is 0, the PMF takes the value as 1 minus theta, right? And if K, let's say, is 1, then again I can just go ahead and give this a try. So let me just go ahead and put K as 1 and see what happens. So if I put K as 1, I will get theta to the power 1, 1 minus theta to the power 1 minus 1. So theta to the power 1 into 1 minus theta to the power 0, and this will be theta. So this is what I have written here, that my PMF will become theta when K will be 1. Is this clear? Now, if you remember, then when I have to find a maximum likelihood, what do we usually do? We multiply the probabilities, right? So probability of x1 into x2, and it tells me that there are 8 sample values that it can take. So I need to multiply x1 into x2 into x3 till x8. But I know that when I am going to multiply this, my sample values are 1s and 0s. How many 1s are coming? 1, 2, 3, 4, and 5. 5 times I see 1. And how many zeros? 3 times I see 0. So if I were to go ahead and multiply these different probability mass functions together, I see that the value 1 comes 5 times. So it will be theta to the power 5. And I see that the value 0 comes 3 times. So it will be 1 minus theta to the power 3. And this will turn out to be my likelihood function. Now, I need to go ahead and maximize this likelihood function. So how will I maximize it? Well, very simple. Just take log on both sides. So if I take log on both sides, I will get ln L is equal to, of course, power comes down, 3 ln 1 minus theta plus 5 ln theta. And now just differentiate it with respect to theta, because the only thing that is under your control is the value of theta, right? So if I differentiate this with respect to theta, I will get this. Very simple. It's a log function. So differentiation of ln 1 minus theta will be 1 minus theta into minus 1. Differentiation of ln theta will be 1 by theta. So when you go ahead and you solve for this by equating it to 0, the maximum value of theta will come down at 5 by 8. So we now understand, this is very interesting, right? If you notice that there were 8 sample values here and 1 was coming 5 times out of those 8 times. And that is exactly what my MLE is coming. So I want you to think kind of whether this is just something that happened by coincidence or whether this will always happen. Okay. So here we have found out that the maximum likelihood estimate of theta is going to be 5 by 8. Okay, let us go to the next question. It says, your neighbor has 2 children. You learn that he has a son, Joey. What is the probability that Joey's second sibling is brother? Now, see, we know, so whenever we do these kind of questions, we know that the sample space usually for 2 children can be boy, boy, girl, boy, boy, girl, and girl, girl. These are the 4 things that can happen if I am planning 2 children. The first can be boy, second can be boy, first girl, second boy, first boy, second girl, and both girls. But here, it is already given to me that the first is a son. So if it is already given to me that the first is a son, then ideally I cannot go ahead and I cannot consider that I can have both of them as girls. This is not possible. I cannot have both of them as girls. It already tells me that I know that not first is son, one of them is son. I know that one of them is son, right? So I cannot consider my sample space consisting of GG. So one of them is son means a B needs to come. Now, it says, what is the probability that Joey's sibling is a brother? The other one is also a son, which means this. So I have this as my favorable, and I have these 3 as my total, right? So it is going to be 1 by 3. This is going to be your answer. Okay. Okay. Come to the next question. Again, this is a sample paper question only. So it says 2 cards. This is very good question. I loved this question. It says 2 cards from an ordinary deck of 52 cards are missing. So think about this. You can consider this missing as you have drawn 2 cards out of a deck. So it's like this. I have a deck of 52 cards, and out of these 2 cards, I have drawn out 2 cards. Right, which means the remaining cards I have are 50. Now it says, what is the probability that a random card drawn from this deck is a spade? So if you know, we know that there are 13 spades that I should have, 13 diamonds, 13 hearts. We know that, right? But now it is saying that I need to draw a spade out of these 50 remaining cards. But here is the thinking that should start. It is possible that the first 2 cards that I lost, that I drew, both the cards were spades. I have lost both the spades. In that case, I will only be left up with 11 spades and 50 total cards. It is also possible that I have just lost 1 spade, which means that out of, and 1 other card, which means I will be left up with 12 spades. Out, I have to draw the probability of drawing any one of these 12 spades out of 50. And it is possible that I would have lost none of the spades, right? And I've just lost 2 random other cards, right? In which case, I have all these 13 spades intact, and I have to find probability of drawing one of these out of the 50 cards. So you need to go ahead and you need to make these cases. So let's say that E is the randomly drawn card is spade, and Fi represents that spades are missing from 50 card deck for I, 0, 1, 2, etc. Right? I need to go ahead and I need to find the probability of E. What is E? What is the probability of drawing the spade as the card? This is the first one. This says F0, which means 0 spades were missing. All the spades were intact. It's like this one. All 13 spades were intact. I did not lose any spade. These 2 cards that I drew were some other cards that I missed. Maybe I missed a diamond. Maybe I missed something else, a heart card, but I did not go ahead and miss a single spade card. So this is what it says, that given I did not miss a single spade card, what is the probability of drawing a spade card, right? Then this is that I missed a card. One was a spade card, and given I have one less spade card, what is the probability of drawing a spade card now? And this is that I have missed out two spade cards. Now, what is the probability of drawing a spade card? So this is what is going to be probability of E. Let us go ahead and find this out. This is when I missed 0 spade card. So I have all the 13 spade cards intact. Out of the deck of 50 now, 2 cards are missing. So it will be 13 by 15. Into, when will that happen? How many cases can be formed where I missed 0 spade card? Well, I know there are 13 spades card. So out of 13, I missed 0, 13C0. Out of the remaining 39, I missed 2. And divided by, out of total 52, I missed 2. Let's look at the second one. This says that I have missed 1 spade card. So I have 1 less spade card. There were 13. Now I just have 12. Out of the total, 2 cards are missing. So 50 total cards. So 12 by 50. And how many ways can be formulated in which I can miss 1 spade card? I can miss 1 spade of 1. I can miss a spade of 2. I can miss a spade of queen, a spade of jack. So out of those 13 spade cards, I've missed 1, right? So 13C1. Out of the remaining 39, I have missed 1. And out of 52, I have missed 2. Plus, similarly, you continue the third one. So out of the total 2 cards I have missed both the spade cards, which means I'm left up with 11 spade cards out of 50. So this is what it is here. Into, I have missed 2 from the 13 spade cards. So 13C2. I have missed none from the other cards. So 39C0 upon 52C2. When you solve this, you will get the answer as 1 by 4. So the answer to this question will be 1 by 4. This is a very good question testing how you can solve the questions related to probability. Okay. Fine, let's go to the next one now. And this is a non-sample question. This is the only question I added because I thought maybe it's a good idea to give you some background of trigonometry also, the kind of questions that can come. If alpha and beta are solutions to the problem cot x is equal to minus root 3 in 0 to 2 pi. Now just tell me something, okay? See, whenever I am solving these kind of questions, it is very important that you know which function takes which value where, right? So, there is something which is called as trigonometric circle, which you can go ahead and you can just learn how this is formulated so that you know that, okay, my sine theta takes this value here. And then, my cot theta takes these values there. And then, etc., right? For tan theta also, you can do it. So you need to go ahead and take into consideration how, at what point, which function takes what value. That is going to be very helpful for solving these kind of questions. Okay, let's go ahead and have a look. So it says cot x is minus root 3 in 0 to 2 pi. And alpha and beta are solutions of this. And alpha and gamma are solutions to cosec x being minus 2 in 0 to 2 pi. Then what is the value of this? So, what we can do is we can begin by saying that if cot theta is minus root 3, right? Then in 0 to 2 pi, right? Pi we know is 180 degree, right? So 0 to 360 degree, then x can be either 5 pi by 6 or 11 pi by 6. This is what can happen. To go ahead and to give you a circle, I'm making it for cot theta. It is just going to be helpful for you but I want you to understand this well, okay? So let's say that. Let's have something like this, right? And so this is 0, okay? Then let me draw a line from here, right? Let me draw a line from here, and let me draw a line from here. Okay, this is cot 90, right? Then I will keep going down, cot 60, which is 1 by root 3, cot 45, which is 1, cot 30, which is root 3. I hope you know these values. Cot 0 is undefined. Okay. And then I will just draw exactly like this here, right? And here I've just gone ahead and drawn these. So basically we need to complete this circle, right? So then you have one more thing. Even if you remember this for one of sine and cos, then you can do it for others. You can do sine by cos, you can do it for tan, then 1 by tan, you can do it for cot, etc., right? So then cot 330 is going to be minus root 3. Cot 315 is going to be minus 1. Cot 300 is going to be minus 1 by root 3. And then cot 270 will be 0. Now you just have to keep repeating. So how will I repeat? Look at this line that I had drawn, no? This line, right? So I just have to write the same value here. So if this was 1 by root 3, this will also be 1 by root 3. If this was 1, this will also be 1. If this was root 3, this will also be root 3. If this was undefined, this will also be undefined. If this was minus root 3, this will also be minus root 3. This is minus 1, minus 1. This is minus 1 by root 3, minus 1 by root 3, and then you complete it. Okay? So I went till 270, then this will be 240, this will be 225, 210, 180, 150, 135, 120, and 90. So now we wanted to check where it is taking the value minus root 3, which is here, and just opposite to this, I am taking the value of minus root 3 here, right? So ideally it is 5 pi by 6 and it is 11 pi by 6. You can also write this in terms of pi. So you can start from pi by 2 and just complete it, right? This will be your pi here. Just complete it, huh? So you can go ahead and do it in that aspect also. So anyways, coming back, so cot can take, when cot x is minus root 3, x is 5 pi by 6 and 11 pi by 6. Similarly, if cosec x is minus 2, x is going to be 7 pi by 6 and 11 pi by 6. Now note that they have one common factor, which is alpha. And I'm getting a common factor here also, which is 11 pi by 6, right? So this becomes my alpha on both sides, which means that this will be, one will be beta, one will be gamma. So I have got alpha, beta, and gamma. Now it just says what? Find alpha minus beta upon beta plus gamma. So alpha minus beta will be 11 pi by 6 minus 5 pi by 6, 6 pi by 6, which is pi. And beta plus gamma will be 12 pi by 6, which is 2 pi. So when you find alpha minus beta upon beta plus gamma, it will be pi by 2 pi, which will be half. So we see that the answer to this is going to be, okay, let's go to the next question. Very good question. So person A's utility function is given by x1 square plus x2 square, and both the goods prices are the same. Then it says which of the following is true. Consumer consumes 1 and 2 in 1:1 ratio. Only consumes good 1, only consumes good 2, is indifferent between the two goods. So now think about this. If you closely look into it, The utility function is x1 square plus x2 square. If I find out its MRS, it will be mu x1 by mu x2. So this is going to be 2x1 by 2x2, which is going to be x1 by x2. Then I need to ask how this MRS changes as x changes, x1 changes. And I get, if I differentiate this, I get 1 by x2, which is greater than 0. Which means that this is not the well-defined preference. This is a concave IC, right? It has increasing MRS. As x1 increases, MRS is increasing, right? So if my MRS is increasing as x1 increases, it means that I have concave ICs. And we know that for concave ICs, we do not have, we don't see that where my IC is being tangent, because it happens here. If my budget line is this, then we will get the solution at the extremes, right? And in this case, when the slope of budget line is 1, when prices are equal, then I am indifferent. I can either consume on the x-axis or y-axis, but I can't consume both, right? So I will either be consuming good x or I will be consuming good y. So answer to this question is this. Consumer is indifferent between good 1 and good 2. Okay, come to the next one. A monopolist faces P is equal to 10 minus Q and has, this is good question, monopoly has constant cost of 5 for the first 2 units of output and then it decreases to 3. Many people do this wrong. बहुत गलत है. You see, it says for the first 2 units, your cost is 5. It does not mean that if I am producing 3 units, then per unit cost is 3. No. Only the third unit will cost me 3. The first 2 will still cost me 5. What people do, and I will just tell you, which is what is wrong, is that they say, okay, my marginal cost is either 5 when x is up to 2, and my marginal cost is 3 when x is greater than 2. So what they do is, suppose you go ahead and you say that, okay, I want to produce higher units, then my marginal cost per unit will be 3. Suppose my output is 10 units. Then my marginal cost will be 3. No, the first 2 units will still have a marginal cost of 5. It does not mean that out of these 10, even the first 2 costed you 3. No. The question is saying monopolist has constant unit cost of 5 for the first 2 units, which will keep intact. So in this case, what I'm going to go ahead and do is I'm going to rewrite this in a bit different way so that we understand it very well. So what we are going to do is, suppose I want to break this. This 5 can be written as 3 plus 2. So even when I produce 2 units, I'm going to incur this 3 rupees plus additional 2 rupees, right? When I produce 1 unit, then also I'm going to incur this 3 rupees plus 2 rupees, right? This is what I'm going to do. So till the first 2 units, can I rewrite this as 3Q plus 2 into 2? 3Q plus 4. Now what this does is, when you go ahead and you say, I am producing just 1 unit, I am going ahead and I'm saying I am producing just 1 unit, then I am saying that, look, my cost is going to remain the same. It is going to remain at 5, right? When I produce the second unit, 2 equal to 2, then my cost is going to be 5 into 2, which will be 10. But the moment I start from the third unit, when I produce the third unit, then my cost is going to be 3 into 1 plus 10, which is going to be 30. So if I go ahead and I start from the third unit, when I say that I am producing the third unit, then from the any unit above the second unit, I see that my cost is going to take something like this form. That now it's 3Q, but for the first 2 units, I have gone ahead and I have incurred those additional 10 rupees, right? This is what is going to go ahead and happen in this case. So this is another way of going ahead and looking into this, that, you know, if I go ahead and I produce anything more than the first 2 units, then I need to go ahead and pay for the first 2 units 5 rupees. And from the third unit onwards, my cost is going to be 3, right? So now how do I go ahead and how do I solve this kind of question? You can go ahead and break this function. So let's say that the demand curve is given to me as P is equal to 10 minus Q. Then my total revenue will be 10 minus Q into Q. This is going to be 10Q minus Q square, and my marginal revenue will be 10 minus 2. This is my marginal revenue curve. So if I were to plot this, when my Q is 0, my MR will be 10. And when my MR is 0, my Q will be 5. So Q, O, MR. My MR is 10 here, and my Q is 5 here. This is my MR. Okay, now look here. For the first 2 units, I am incurring a constant cost of 5 for the first 2 units. So for the first 2 units, my marginal cost is like this. This is what my marginal cost, not 2. For the first 2 units, your marginal cost is 5. So I'm incurring half of this, something like this. My marginal cost is 5. And for the remaining units, it decreases to 3. Oh, did I do something wrong here? No, it is correct. Okay, for the remaining, it decreased to 3. So 2 onwards, 2 is included here, and then it decreased to 3. Something like this has happened. Okay. Now it wants us to find out what is the profit maximizing output. So I have already found out my marginal revenue, right? And now I just need to see where it equates to my marginal cost curve. So what am I going to do? I'm going to say, okay, my marginal revenue is 10 minus 2Q. I will not equate this to 3. If I equate this to 3, I will get the answer as 7 by 2, which is 3.5. But in this case, I am going ahead and saying that this is directly equated to my marginal cost here. I need to go ahead and consider this. But here is the interesting part. The total cost that I formulated here from the second unit onwards is 3 per unit. But for the first 2 units, I have incurred an additional 4. So therefore, even if I were to find the marginal cost of this, I have accounted for the fact that the first 2 units are 2 rupees expensive by doing this. Then also my marginal cost is coming as 3. So I am not equating because of this direct reason that it is given to me as 3, but because they told me that the first 2 units are expensive, 2 units more. It's 2 rupees more than the earlier one. So I've accounted for the fact here. And then I found out what my marginal cost is, and it still comes out to 3. That's the reason I will now equate it to 3. And I will get the answer as 3.5. So try to understand what I am doing. Okay. Just don't go ahead and equate it like that. So the answer is going to be 7 by 2. If you find this a little tricky, you can just find the profit function also, which will be TR minus TC. This will be total revenue. This will be total cost. Differentiate this and you will get the same answer. So I am accounting for the fact that the first 2 units are more expensive, that each unit is worth 5 rupees. And then I'm coming up with this total cost function. So think about this. If you would have gone ahead and thought that maybe the 5 rupee curve itself is cutting here. Can this happen? This is what you need to go ahead and think, that this is not possible. Because when my MR is 5, when my marginal revenue is 5, okay, sure. I'll explain it, Tanishta. So when my marginal revenue is 5, then so if I put, if in this equation, I go ahead and put 5, I will get 2Q is equal to 5 and I will get Q as 5 by 2. So why should my profit maximizing quantity be 2.5 and I can maximize my profit at 3.5? There is no reason for it, right? So when why should I be producing 2.5 units when I can in fact be producing 3.5 units? That's the first thing. Second thing, this equation holds as good as Q up to 2. But here I'm getting Q as 2.5. So this is a deviation from what I did. So this is incorrect. Okay, Tanishta. So I'll just explain how I got this total cost function again. So basically what it is saying is, it is saying the cost is 3 per unit after you have produced the first 2 units. So imagine this. I produced my first unit at 5 rupees. I produced my second unit at 5 rupees. And then the third unit onward, I'm producing it at 3 rupees. Even if it is a continuous function, only till the first 2 units, I incurred 5 rupees. But now I need to produce a function out of it. How will I produce a general function that takes care of the fact that from 3 units onwards, I consider the first 5 rupees that I have incurred? So what I do is, I say this 5 is 3 plus 2. And this 5 is also 3 plus 2. So now I can say that, look, this also incurred 3 units, 3 rupees, but additional 2. This incurred 3, but additional 2. And then this incurred 3, 3, 3, and so on. So what I do is, I say, look, definitely 3 per unit is coming. That is not going anywhere. 3Q is there. But then for the first 2 units, I have these 2 extra. So 2 plus 2 is 4. That means for first 2 units, I have gone ahead and incurred this extra money of 4 rupees. And then from third unit onwards, I am safe. From third unit onwards, I just incurred 3 rupees per unit. So this means that if I were to produce 3 units, what would have been my cost? First unit at 5, second unit at 5, and third unit at 3. Total cost would have been 13. And when I put in this function, Q equal to 3, I get 9 plus 4, which is 13, which is the same thing. If I were to produce 4 units, first 5, second 5, third 3, and fourth 3, that means I would have incurred 16 rupees. Let me just check here. So 3 into 4 plus 4, 12 plus 4, which is 16, which is giving me the correct answer. So whether I add it in this way, that first 2 at 5 and then the next 2 at 3, or I just make this function that every unit definitely 3, but then for the first 2 unit, I must have incurred 2 extra, which means 4 rupees for the first 2 units. It gives me the same answer. That is why I am able to make this, right? If not, you can just go ahead and give this a try. Equate different marginal costs to MR and see where you make sense out of it. So when I equated marginal cost of 5 to my marginal revenue, I got Q as 2.5, which is wrong because marginal cost of 5 only holds till Q equal to 2. and I'm getting answer as 2.5. This is incorrect. So which means that I must equate this marginal cost to my MR. And when I equate this to this, I get the answer as Q equal to 3.5. And this is correct because this marginal cost was for Q greater than 2. And here also we see the same thing, that Q is coming greater than 2. So it's a very good question, but I would really love if you understand how you formulate the total cost in this. Is this making sense? Okay, so now let's go to the next question. It says Charu loves apples and hates bananas. Her utility function is given by this. Sandeep likes both apples and bananas. Charu has initial endowment of no apple and 8 bananas. Sandeep has 16 apples and 8 bananas. Price of banana at which Sandeep can consume exactly 16 bananas is. Again, a sample paper question. See, ideally it is asking me to find competitive equilibrium. If I want to find competitive equilibrium, I need to understand that, Charu hates bananas. So if it were up to her, she would have consumed 0 bananas and all apples. And this is what she's going to do. So what I do is, I say, okay, this is my total endowment. And then I say, because she only loves apples, she wants to go ahead and spend all her income on apples. How many apples can she consume? Her income divided by the price of the apples. What is her income? She can earn income only from her endowment. This is her endowment bundle. So 0 into PA plus 8 into PB. This is her income, right? 0 into PA plus 8 into PB. This is her income divided by the price of apples. So the number of apples that she can consume is 8 PB upon PA. Now let's talk about Sandeep. He has quasi-linear preferences. So what will he do? He will go ahead and consume in such a way that his MRS is equal to price ratio. So I find out his MRS and I equate it to the price ratio. What is his MRS? Differentiate with respect to A. This will be MUA. Differentiate with respect to B. This will be MUB. And equate it to the price ratio. When I do that, I get that B is this much. B is PA by PB whole square. So Sandeep will consume bananas. Sandeep will also consume apple. Both goods are good goods for him. And Charu will only consume apples. But now, the question says that we want Sandeep to consume all the bananas. We want Sandeep to consume 16 bananas, right? So I want Sandeep to consume all 16 bananas. So instead of B, I need to put 16. So this is what I do. I just put 16 here. And when I put 16 here, I get 16 is equal to PA square by PB square. So I get 4 is equal to PA by PB. This is what has happened here. Now, it tells me, if you go back somewhere, that we want to find the price of bananas. If I want to find the price of bananas, then I will keep the apple at the numerator price, which means I will keep PA at 1. So if here I put PA as 1, I am going to get PB as PA divided by 4, which will be 1 by 4. So the answer of PB is going to be 1 by 4. Very easy question, but you can do it after you understand general equilibrium very well. Okay, come to the next question. This is again a sample paper question. It says indicate which of the following statements are true. When output gap is 0, economy is on its short run Philip curve, but converse is not true. So just think about this. output gap is the gap between actual and potential output. Now, in the long run, my actual output is equal to natural level of output, is equal to potential output. So in the long run, my AS curve is vertical. I have this as my AD curve and this as my short run AS curve. In the long run, where the short run AD and AS meet, it is equal to where the long run AS meets. So in the long run, your short run Phillips curve and long run Phillips curve also meet. The long run Phillips curve is vertical at the natural level of unemployment. And the short run Phillips curve is, of course, downward sloping. Now, we understand that if it is long run, then I am at point A. And this A represents that I have natural level of unemployment. That means I do not have any additional unemployment. I'm at full employment level. My output is also at full employment level. So if that is the case, that my output is at full employment level, what should be the answer to this? It is correct. Output gap is 0. That means I'm in the long run. Economy is on its short run Phillips curve. Yes, I still have this point on short run Phillips curve also. This point A lies on both short run and long run Phillips curve. It says, but converse is not true. That's correct. If Y is equal to Y star, you will be on short run Phillips curve. Whenever you will be on short run Phillips curve, Y is not equal to Y star. So this point Y is not equal to Y star. This point Y is not equal to Y star. There is only one point on the Phillips curve where Y is equal to Y star. That point lies on the Phillips curve. That is true. But not all points of Phillips curve represent Y equal to Y star. So the converse is not true. This is the correct statement. Now just see this. Output gap is ratio of actual to natural real GDP. See, you know, in the answer key, they have said it true, but I would not agree to it completely. Usually we don't talk it as ratio. Usually we say it as a gap between actual and potential GDP. And if I were to find it in percentage, then I would say, what is the gap between actual and potential GDP divided by potential GDP into 100. This is your answer in terms of percentage. So we can say that, you know, ratio of actual to natural GDP may give you an indication between what's the gap between the two. Just for example, if my actual GDP is 100 and my full employment is 400, it means I'm 1/4 to the full employment level, right? This also gives me a good enough hit, but actually my gap is what I want to cover, which is 300. This is a more realistic thing that I want to do. Okay, come to the third one. A shift of supply curve results in negative output gap. This is definitely false. Why? Because they did not give you where this shift is. Is this a rightward shift? Then you will have Y greater than Y star. Or is it a leftward shift? Then you will have Y less than Y star. So unless you tell me which shift, I can't tell you whether it is a negative output gap or positive output gap, right? And last says, when output gap is 0, inflation is steady. This is correct. Let's have a look here. So what you can do is, you can write the equation of the Phillips curve, which is this. Now, output gap 0 means Y is equal to Y star. If Y is equal to Y star, U will be equal to U star. If U will be equal to U star, this will be 0. If this will be 0, pi will be equal to pi. So I will have a stable inflation. And if I were to assume that a person is having rational expectations, that his expectations are correct, then this pi e ki jagah pe I can just write pi t minus 1. My expectations are absolutely correct, right? And it's just as the previous years. So what I can do is I can simply say that this year's inflation is equal to last year's inflation, which means that it is a stable inflation. So yes, that statement is in fact correct. Okay. Come to the next question. The function is defined as this. For how many positive values of a is the function continuous for all x's? Now just take this. Let's say, see, I am only concerned about two values, because if I look at the numerator, I can just break this up. X square minus 4 can become x minus 2 into x plus 2. And x minus 1 will remain as it is. And if I talk about the denominator, I can write it as x minus root a into x plus root a. Right? Now just think about this. If root a is 2 or minus 2, then a will be 4. Right? If root a is 1 or minus 1, then a will be. If I have to take a as 4, if my a is 4, then what is going to happen? Well, very simple. In the denominator, it will become x square minus 4. This will simply cancel out. I will get a function x minus 1. And this is continuous everywhere. X minus 1 is simply a line which is continuous, right? So when I talk about this function with a equal to 4, it becomes a continuous function. But now let's say that a is 1. So if a is 1, the denominator will become x square minus 1. So when I break the denominator, this is going to be what? This is going to be x minus 1 into x plus 1. And my numerator will be x square minus 4 into x minus 1. So this will get cancelled. But in the denominator, I will be left up with x plus 1. And I cannot have my denominator as 0. So I will have a discontinuity at the point my denominator is 0. Right? So when I took the value of a as 1, I saw that this point occurs. And when this happens, my denominator cannot be 0. So this is a point of discontinuity when a is 1. And then I just checked it for 4 and 1 because they linked to the numerator. But for any other a, this is possible. That, suppose my a is, let's say 9, right? So what will I have? I will have something like this. X square minus 9. So I will have something like this. X minus 3 into x plus 3. And I don't want my denominator to be 0. So I don't want my x to be 3 or my x to be minus 3. So for any other value, I will get 2 points of discontinuity, right? Whatever a I put in here, I will get 2 points of discontinuity. But when I have my x at a, because one factor gets cancelled, I have 1 point of discontinuity. But the best is when I have x as a as 4, then I don't have any point of discontinuity because this entire term just goes away. The denominator just goes away. So which means that there is a possible value of a such that my function becomes continuous throughout and the discontinuity just goes away. Okay. Come to the next one. The function is differentiable, strictly concave, strictly increasing, and satisfies f0 is 0. Which of the following statement is true about this function? Okay. There are multiple ways to do this. I have done using Taylor's approximation, but it is up to you what you want to use here. So what I have done is, look here. If I were to find Taylor's approximation of fa, it is fa plus f dash a x minus a, right? Now, when I say that I approximate something to something. That, let's say that, find out the value of the function. A big function is given, and then I say it's approximate. Suppose something like this, x plus 10 to the power 100. And I need to approximate it to value. Then what do? We say that its approximate value will be something. And that approximate value for concave functions is its upper bound. It is given to me that the function is concave, right? So whatever approximate value I have, that is going to be the upper bound. Usse zyada nahi hoga. That's the approximation. That's the highest value it can take. So the approximation is it is bounding it above. What does it mean that it is bounding it above? That whatever approximation I have found out, it is the value of the function at max. So the value of the function is less than or equal to that value, right? Now what you can do is, you can just put, this will be f of x function, right? Here also. Now what you can just go ahead and do is, just put x equal to 0. So let's check what happens at x equal to 0. So I will have f of 0 less than equal to its approximation. What is the approximation? F of a plus f dash a x minus a. But this gives me that f of 0 is 0. So if f of 0 is 0, then f of 0 ki jagah pe I can just put 0. And this 0 minus a will simply be minus a. So I will get 0 less than equal to f of a minus a f dash a. And now I will just take this to the other side. So I will get a f dash a less than equal to f of a. So f dash a will be less than equal to f of a by a. So this is what your answer is. So the answer is supposed to tell what is the relationship between f dash x and fx by x. Now just think, supposedly, I want to just give you this homework. What would be the relation when your fx is a linear function? So suppose my fx is x plus 10, right? What is the relationship between fx and f dash x by x? Just try and find this out. Okay, similarly, you can actually go ahead and do it for others also, but make sure that you, so it says f of 0 is 0. So which means that here also, let me just take a linear function like this. So this satisfies the condition that f of 0 is 0. Right? So just go ahead and try this and see what relation you will get. Okay, now come to the last question. It says you're given a function, and this function is given by 3x plus 4, and 3x is in the mod. For which values of the following function does the graph intersect the function? These are the 4 functions. It says which of them will intersect this, right? So what you can go ahead and do is, you can just open up this function. So when I say 3x plus 4, it is going to be 3x plus 4 when x is greater than or equal to 0. When I open up the mod, and it is going to be minus 3x plus 4 when x is less than 0, right? Now, what I'm supposed to do is find the point of intersection, right? So what I do is, first I will, to find intersection means you have to go ahead and equate. Ek value of y ye raha, the other value of y is this. You just have to find which x they intersect at. So supposedly I start with the first one with x minus 2. So what I do is, I say let 3x plus 4 equal to x minus 2. I start with this. So when I equate 3x plus 4 to x minus 2, I will go ahead and get 2x as minus 6 and x as minus 3. But I can only solve this intersection as long as x is greater than or equal to 0. And the x that I'm getting here is negative. So that means this is not the correct intersection. This function cannot intersect because this line only is valid for positive x's. And the point where they intersect is when you have x as -3. So if I were to show this, it's something like this. This is my 3x plus 4 graph. This is my line. Let's say this line is x minus 2. If I were to extend this, if I were to extend this somewhere here, something like this, they would have intersected at x equal to -3. These two curves would have met, something like this. They would have met at x equal to -3. But this is a mod function. It does not exist for negative values. And for positive values, there is no intersection. So therefore, the first part is incorrect. This function does not intersect this. Now look at the second one. Let's say I need to check for 2x minus 2. So I equate 2x minus 2 to 3x plus 4. And I again get x as -6. But this is 3x plus 4 part. This function is only valid as long as x is greater than or equal to 0. This is also incorrect. Then I check for the third one. 3x plus 3 and 3x plus 4. You don't even have to check. These have the same slope. Iska bhi slope 3 hai, iska bhi slope 3 hai. The coefficient, right? So they have to be parallel lines. They cannot intersect. So this is also not possible. You can also check here. If I equate 3x plus 4 to 3x plus 3, I get 4 equal to 3, which is not possible. This is incorrect. Finally, I come to the last one, 4x minus 2, and I equate it to 3x plus 4. So when I equate 4x minus 2 to 3x plus 4, I get x as 6. So 4x minus 2 should have been a down, So if you have y is equal to 4x minus 2, you can just go ahead and plot this, that when x will be 0, y will be -2, right? And then as you keep increasing x, y will keep increasing. So when x is 0, y is -2. It starts from here, but then it increases. And now these two actually, they meet. Where do they meet? They meet when x is 6. So I do see that they are intersecting. This is the point of intersection that I have, right? So which means that this fourth one is correct, because when I combined this function with this, I got a positive intersection. And this is correct, that I wanted x to be greater than or equal to 0, and this is happening. But this is not enough. I have done it partially. I've explained it partially. Try it for the other side also. So maybe that the line does not intersect on the positive quadrant, but it may intersect on the negative quadrant, right? So you should complete your analysis. So for x less than 0, my function was -3x plus 4. When I equated it to the first function, to this one, I found out that x is coming positive. But I wanted x to be negative, which means no. It cannot intersect even on the negative part, because it is giving me positive x, when in fact I wanted negative. Same you can check for the second one. It is giving me positive. I wanted negative. You can check for the third one and fourth one. It will always give positive. You wanted negative. So no other intersection possible. Only this function intersects this modulus function once, which is on the positive side when x is 6. And that's the answer. So we will just mark it with